Good afternoon, guys. This is your instructor for the online C++2 class. I am showing you the modules page of our Canvas website. And as you can see, we are covering one chapter in 2 weeks. So I have posted chapter 7 assignment help video, chapter 8 video lecture and assignment help. Similarly, for week 6 and 7, which covers chapter 9, I'm making this video so you can learn from me what is the content for chapter 9 and how you can use the information to do the chapter 9 quiz as well as the chapter 9 assignment. Under week 6 and week 7, you will have this a link which will take you to the video I'm making. So as of now, it doesn't exist, but it should be there after I have done posting this video. So without any delay, let's go to the book. I have access to the ebook, and therefore I will show you the chapter 9, which is about records or struts. Mainly we'll be talking about struts in this chapter. Coming from chapter 8 about arrays and other elements that you have learned, this is going to be a very logical transition learning about struts. So we'll learn how learn about records or struts, examine various operations on struts, explore ways to manipulate data using struts, learn about the relationship between struts and functions, examine the difference between arrays and struts. So this is a very good point you will learn. It will help you for the quiz as well as for the assignment. Discover how arrays are used in a strut and learn how to create an array of struts item and learn how to create struts within a struts. So this is what we'll be going through. What we learn in chapter 8 is about arrays, and when you are thinking about arrays, it's a group of group values of same type is what we were storing. You will declare an array and it will have 10 elements of int or 10 elements of string or any data type available, but the elements are of the same data type. They are homogeneous. When you need to capture information that is heterogeneous, that's when struts comes into picture. Struts allows you to capture various data types in a group, various attributes of different data types in a group. So here is an example that the textbook talks about, that if you were to think about a student record or student strut, then we might store student's name, which is a string, student ID, which could be a numeric, GPA, which is a character, it could be a decimal, and then course is taken, how many courses, and course grade. So there is a variation between the data type that we will be using for the different elements you are looking here, and an array cannot answer that, provide a solution to this kind of a problem, and that's when we will declare struts. The key word strut is a reserve word, so it is something that C++ uses internally, and therefore you cannot declare a variable with that name. The general syntax of a strut is the following. You will have the keyword strut. You will give a name to your strut. It could be like student record, open curly brace and a closing curly brace with a semicolon. And inside those curly braces, we'll define the data type and the identifier that we want to use for the different elements within the strut. Here we can see an example. So if you have a strut called house type, you want to store the style as a string, number of bedrooms in that house, number of bathrooms, number of cars garage, years built, finished, square footage. They are all integer. Then you have the price, which can be a fraction, so therefore double, and the tax, which can also be a fraction, therefore the data type double. So what does this do? This defines the definition of the strut. Okay, it's a definition. We are not declaring, we are just saying, hey, I'm going to use something like this, so therefore it is a definition. It's not a declaration. Once we have defined this data type, then we can declare variable of this data type. So if we were to declare a variable of this strut data type, then we'll basically be storing some memory in our computer's RAM. So it would store something like this, where you'll have the style given some memory, you will have the number of bedrooms and the other elements within the strut. All of them will be immediately allocated some memory if we declare a variable of this type, house type. So how do you declare a variable for int? You write int and then you write number of bedrooms, right? How do you declare a variable of this strut? You just say the name of the strut and a name of the variable you want. So here we are using new house. Okay. You can also declare and initialize or define, excuse me, and declare a variable immediately. So here we have the strut house type. Everything looks good until the closing curly brace, but rather than putting the semicolon immediately, we type temp house. So what we are doing is we are defining the strut and we are creating a variable which is called temp house, and that will be available to the all the methods available within that class. Okay. How do you access the elements within the strut? Now this is slightly different from what you have learned in the array, where we are using the index element, the index of the element to grab the value from an array element. Here, when we are accessing the members or the elements within the strut, we will use the name of the strut variable dot and then the member name. So imagine you have a strut called student type with different elements or different members, and you are defining a two variable called new student and student. So if you want to store something in the new student's GPA, you will say new student dot GPA equal to 0.0, and similarly the statements like new student dot first name is John and new student dot last name is Brown. So this is somewhat of a different from what we have learned. If you were to write these three statements in your code, this is the outcome which will happen. The memory that is reserved will get the values that we are assigning to those strut members. You can also write console input, whereby you can say new student dot first name. So anything that is entered by the user on the console will be stored in the first name. You can also write something like this, where you are saying new student dot test score and new student dot programming score. Therefore the two integer values from the keyboard will be stored in these two variables or these two members of the strut respectively. Because depending on the data type of the strut members, you can apply arithmetic operations such as the following. But mind you, because of the data type, these operations can fail if you abruptly do something like this at runtime. So here we have another if-else if statement, where we are saying if the score is more than 90, then we are setting the course grade for the new student member, the new student strut variables course grade member to A, B, C, D and F. Here imagine that you have a house type which was defined before in our previous two pages, and then we are declaring two variable, Ryan's house and Anita's house, and we are storing the values for the members of Ryan house strut with the different values, as you can see here. We can also, instead of giving the value, we can get it from the console, as you can see here. So if the input is ranch for 350,000, then it would basically going to store those three values in the three members, the style, the number of bedrooms and price respectively. And here is an example of how the information is stored, somewhat repeating what we have learned. Now imagine that you have a strut called new student and you have another variable of the same strut called student. So you can basically take the value from the new student and deposit into the student. This kind of operation was not allowed in arrays. Basically you can't say that array A, I just want to put in array B. That won't happen. You have to copy the individual elements of the array from one array to another. But in case of strut, hey, guess what, we can take one array, one strut, which a strut variable such as new student, and take the entire member information and copy it into another strut variable called student. So this is somewhat of very useful when it comes to programming. What we just learned is, rather than assigning one strut variable to another, we can also assign the individual elements or the members within one strut to the members of the another strut variable, as you can see here. But if you can do it the whole strut level, why not, provided that's what you are expecting. We can also do relational operators. So we can use that, if the first name is equal to the first name and the last name is equal to the last name for the two strut variables, then do something. So this is very useful. It's just that strut is a data, structure. It allows us to structure our data which is heterogeneous, and therefore we are not comparing two struts. We are basically comparing two primitive data types within the strut variable. So this kind of operation is very much possible in struts. As we talked about input and output operator, we can get the console input and console output for the members of the strut. We can't say, whatever the user type goes into the strut. That's impossible, because a strut in itself is nothing. It's just a container. So therefore, whenever we are using, we have to specify the member variable within the strut. We cannot do input and output directly on the strut variable, because those aggregate operations are not allowed. We can pass a strut by both as a value or by reference, and a function can return a value of type strut. So these are somewhat differences that you may see when you are comparing the strut with a array, because an array is something that we cannot return from a function, and when we are passing an array, the array is always passed by reference. Although we have learned that we can use the const keyword and make it read only, but in case of strut, we do have flexibility. We can pass in strut by as a parameter to a function, either by value or by reference. Okay. So here is a dummy function that they have written called readIn, and it takes a strut as an incoming parameter, and here we have some console input. It's passed by reference, so we have some console input to store the value, and a little bit of if logic to determine the grade, course grade for this student. And if you were to call it, you would write like this. It'll get the call, it'll call the readIn function. The readIn function stores the appropriate value in the variable new student, which is passed by reference. Okay. Similarly, you can have another function which is print student, and you're passing it by value, where this function print student is responsible to simply just generate the output and display it on the console. So here is a very quick cheat sheet between the arrays and struts. Can you do arithmetic operations on array as aggregate? No. And on strut? No. Assignment operator we cannot do on array, but on strut, yes, as you have seen in few pages ago, we can do that. Input output we cannot, except when it is string on an array. Comparison, again, please note these are at aggregate level. We cannot do the comparison between two arrays or two struts. They are totally different memory in our computer RAM, therefore we cannot do that. Parameter passing, array can only be passed by reference, and strut can be passed both by reference and value. Function returns a value of type array, not possible. Can it return a variable of type strut? Absolutely. Can we have arrays within the strut? Definitely. Consider array as just another member within the strut. So you can have like list type, where you have an array and you have a list length. So this is basically an easy way of declaring an array, perhaps, where you are storing the elements of array in the strut and you have the length. So this is how it would be. You have two elements where you have one which is an array and second is just the length. If we were to capture the 0th element in this struts array, you would write int list dot list elim 0 equal to 12. So this is going to put 12 right here. So rather than just writing something like this, we are writing the array variable name in before to access that array element which is part of the strut. So in a nutshell, if somebody were to ask you, can you have arrays within a strut, your answer should definitely be yes. And this is what we were talking about, where the first element or the 0th index position will be stored 12 by the lines written in before. So here we have sequential search. You are passing array, excuse me, we are passing a strut by reference, but we are making it constant, and we have the search item. So we have we are saying list dot item length, which will give us how many elements are in this array, which is part of the strut. And then we are saying list dot list element at the location and looking for search item, which is sent as the second parameter. So this function is basically going to return if the search item is present, or it will return -1. Can we have struts in a array? Well, think about it. I mean, strut is just a way of combining various data types into another new data type. It's a definition, right? So can we have an array of these struts? Absolutely. We can definitely have that. We can say, hey, I have employee type as my strut name, and I'm going to create an array of that strut. Rather than creating one employee, I'm going to create 50 employees, and for each 50 I'm going to capture all these different elements one at a time, and it will definitely is possible. So here is an example where you have an array of strut, and this third position, which is the second index, will in itself have all these elements as part of it. Here is an example where they are reading from a file, and we are using the array of strut using a for loop. We are just setting the values by reading through the file. So good examples of how you can read the information as well as generate the output, which is shown in this small code snippet here. Can we have struts within a strut? Yes, the answer is correct. If you have an employee type with all these different elements that you're capturing for employee, from his demographics to his hiring and quitting information and other identifiers or other information, you can have an array of this long list of elements, or in this case 22 members. Or you can have arrays for different type of employee information and create a parent strut to capture all those individual struts, which captures the different types of element for that array. So for that strut, excuse me. So here we have a name type strut, we have an address type, we have the date type, we have the contact type. And the good thing here is we are using name type to capture the name information. We are having an employee ID, which is just a standalone string attribute. We have address type to capture the address, and we are using the date type to capture the hire date, another date type to capture a quit date. So it's a pretty good use of the date type, so as to know when the individual was hired and when the individual left the company. Contact type will allow us to capture the contact and couple other primitive data type members, which are department ID and salary. So here is a very good example, a practical example of how you can better manage the complexity by creating struts and use those struts in another strut as a parent container. So here's how it will be. You will have a strut within a strut for the name, for the address, for hire date, quit date, and contact, and rest of them are just primitive data types. And how will you set the information? When you are referring a member which is inside a strut in the strut, so you will say the name of your parent strut dot the name of the child strut and the name of the variable to store the information. Mind you, the new employee is a variable that we'll create of the parent strut. The name is basically the name, which is the name of the internal strut. So we don't create an instance of that, we just create an instance of the parent strut. And if you are getting the information for 100 employees, this is how you would loop through it to get the first, middle, and last name respectively. Here is the programming example that the textbook covers about capturing information in for multiple salesperson for the 4 quarters, and expects the information to be generated in this manner from this line all the way until this amount here in the bottom. So this is what is expected. This is a code that you can write in CodeLite or Eclipse for C++ or any of your developer dev C++ or any of the IDEs that you are using. It does expect the information to be present in text files for salesperson ID, month, and sales amount, as could be something like this, and it also expects another file that contains the annual sales report in the above. That's the output, excuse me, that will generate the output as expected by this program, which is shown right here. So in order to capture that, you have a salesperson record where you are capturing this, and a salesperson will have 4 quarters. So there is an array for the quarter, the total sale, and the identifier for the array. You will declare an array of the salesperson, because if there are 10 people working or 10 salesperson, then you will have the 10 strut variables in a fashion of array, where you can store the information. Similarly, the total sales by quarter, you're just declaring an array of double to capture that information. And this is how the information will be stored in the salesperson's list array. So there will be, the first element will have an ID, the sales by quarter, which is an array of 4 elements, and the total sale. And this is how the information will be filled in when the code reads the information from the text file. So the initialization, where how to read that information and store in the array, is explained here. You have, this is the same thing that we were talking earlier about how it will be stored inside. And the getting data in order to generate the output is explained in this another function. You have the sales by quarter, which takes the array of the strut, the list size, and total by quarter in order to calculate that and save it by looping through the array. When you have total sales by person, which is another element requested by this software to be generated in the output, and therefore we have a function for that. And here is the print report, which will print in the exact manner, utilizing the different data captured by the other functions to generate the output in the expected manner. Please go through this, because this will help you understand how we can really use strut from the very defining that to using it to generating output by utilizing other elements you have learned in this in the prior chapters. So this is the entire code listing. One can really use it as an example to generate the exact output. With that, we are in the quick review. So the quick review, kindly go through it. It will help you as you are doing the chapter 9 quiz. The assignment for this chapter are: do the exercise 14, 15, and 16 listed on page 644 and 645 of the textbook. This is due on March 4th. So let's go to the page 644 and look at the exercise 14, 15, and 16. So here is the example. Assume the declaration of exercise 10 and 13. So 10 is on the previous page, and here is an employee type. And there are a couple of variables that we are creating of this employee type strut. Write C++ statement that do the following: 2, 3, 6, 7, and 8. So these are the topics covered. Store the following information in new employee. So if you have a new employee, which is a variable of type employee type strut, then how do you store Mickey Doe? You would say new employee dot name is equal to Mickey Doe, new employee dot PID equal to this number, new employee dot performance rating is equal to 2, and so on. In the array employee, which is right here, this is an array of strut. Initialize each performance rating to 0. So how would you do that? You will write a for loop to loop through the 100 elements of this employee, and for every time you are running the for loop, you will use employees counter dot performance rating equal to 0. So your code might look somewhat like this. Here is the code for A, where we are setting the values for the different members of the new employee strut. And then you have the B, where we are using a for loop to loop through the 100 elements of the employee array, which is in itself an array of strut data type. The C portion of exercise 14 is copy the information of the 20th element of the array employees into the new employee. So you're just taking a strut variable located in the 20th position and you are copying it into the new employee, and that you would do as follows. Because strut, you can do the assignment operator at aggregate level. We are taking the 20th element, which is at 19th index, and putting into new employee. Update the salary of the 50th employee in the array employees by adding 5735.87. Now when it is talking about 50th element, we need to make sure it is at the index 49, and we are using plus equal to the aggregate addition operator to add the value 5735.87 to the existing value in that array, in that array element 49th, and changing the value for the strut member salary. Exercise 15, assume that you have the following definition of a strut, where strut part type, which is capturing part name string, part number as integer, price as double, and quantities in stock as integer. Declare an array inventory of 100 components of a type, parts type. Basically, you have seen the same thing being done right here. This should give you a clue of how to write this line. So this is an array of employee type strut by the name employees, and we are asked to do the same thing, which would look somewhat like this. So you will have an array of called inventory, which is a array of parts type strut having 100 elements. So this is what it would look like for your answer. The exercise 16 is assume the definition of exercise 15, which is parts type. Write a C++ code to initialize each component of inventory as follows: part name to null string, part number to -1, price to 0.0, and quantities to 0, quantities in stock to 0. When you're talking about something like this, where you are asked to initialize each component, immediately you should think about utilizing a for loop, right? So you may write something like this, whereby you will have a for loop, and you are using a for loop, running it for 99, from 0 to 99, which is 100 times, and every time you run it, you're using the counter for the for loop to set the member elements to the defined values as expected by this exercise. The part B is write a C++ code that uses a loop to output the data stored in inventory. Assume that the variable length indicates a number of elements in inventory. So here we are not setting the values, but we are displaying the values. And here we have a for loop which would run up till the length which will tell how many array elements are actually present, and we will generate the output using console out for the part name, for the part number, the price, and the quantities in stock. We'll put an end line and then run it until the array is exhausted, and then we'll display this line every time we are separating first element from the second. So these are what you need to do for this chapter. As I said to you, you will see the assignment 8 video under chapters of week 6 and week 7 after I have posted it, and hopefully it will help you learn about struts. I hope your reservations about strut have been clarified, because it is not very difficult and it's very simple. It allows us to do some fantastic things in real world. Lastly, if you were to tackle Java after this, it is very similar in Java as well to what you have seen as the strut in C++. My information are always on the home page, so if you were to need any help, please reach out to me. I'm here at your assistance so you can get better and hopefully build confidence in programming with C++. Thank you so much. I look forward to hearing from you if you have questions, and hopefully this video helped you on the topic of struts covered in week 6 and 7 for chapter 9. Thank you.